Hello, the first laboratory session is devoted to data preprocessing and cleaning up. The purpose of the session is to study the techniques of the initial data preprocessing for applying machine learning methods. During the session, it is necessary to convert a file with data in mixed numerical and text format with gaps and errors into a file of required data format without gaps, errors, and outliers. We will use Python 3 programming language, Google Colab platform, and Pandas library. However, first of all, we should consider some math basics of data processing and the Python library NumPy. The simplest data entity is a scalar, a single value. A sequence of values is a vector. The most commonly used type for machine learning applications is a matrix. It corresponds to tabular format. A matrix with more dimensions than 2 often are called as tensor. But the point is not how to name data objects. All shown objects can be called a tensor. Or, for example, a 3-element vector can be regarded as a 1-row and 3-column matrix, or even as 3D matrix or a 3-ordered tensor if it is necessary. The main thing is dimension. It shows the number of directions and the depth of each one. The best way to understand these things, as well as working with matrices, is practice. In my opinion, the best Python library for working with tensors, arrays, or matrices, as you like to call them, is NumPy library. So now I switch to Google Colab. You can easily open Google Colab as shown in this screenshot. You need to use your Google account to work with Google Colab. If you are not familiar with Colab, I recommend watching this introduction and this video. Then you should create a new notebook. Please always name your projects, for example, Laboratory 1, otherwise it will be difficult for you to find them. So now we can start to write code. First of all, we need to import NumPy library and give short pseudonym np. And the first point is creation of arrays. For example, we can create vector or row vector using this code. And we can check result of this code. You can see that we have created a row vector. Of course, we can create column vector if it is necessary using the following code. Next, we can create, for example, one element array. We need to point out single element. And of course, it is not very useful to write each element manually, so we can create, for example, zeros array. Or you can create one arrays. Of course, if you want, then you can create a matrix with 2-order, 3-order, etc. And first of all, let's create it manually. We need to specify each rows as a number of elements. Then, after the first row, we can write the second row. In this case, we will create this matrix. And you can apply the functions zeros or ones to create matrices. In this case, we need to specify dimensions, number of elements for each dimension. For example, matrix 3 rows and 2 columns. In addition, we can point out the type of elements. For example, we can create this array and specify type of each element. For example, int 8. It means that each element will be 1 byte. And let's consider how we can create a sequence of elements. We can use the function arrange, and if we specify only one argument, then this function gives us sequence from 0, and the length of this sequence is as value of our argument. But also we can point out start and stop of a range, for example 10 and 20. Excuse me. In this case, as you can see, this value will be used as the start of sequence, and difference between this value and this value will be used as number of elements in this array. Also, we can specify a step. In this case, we need to specify 3 arguments: start, stop, and step. For example, 3. And also, of course, we can create the reverse order, for example, and we can point out a negative step. So as you can see, now the order is opposite. And sometimes you don't know the value of step, but you can point out the number of elements. In this case, we can apply the different function linspace. And we need to point out start, stop, and count of elements, for example, 10. In this case, as you can see, the value of step will be calculated automatically. And the last point about NumPy array creation is functions with prefix like. For example, we can create array, and also we can use the function full if we want to fill in array with specific value. And after that, if we want to create new array with the same dimension as our initial array, then we can create this array using the functions with prefix like. For example, zeros like. In this case, we need to point out also our initial array. As you can see, the dimension of array B is the same as dimension of array A. NumPy array has the mutable type. It means that it is possible to change an array. For example, let's create an array, name it A, and for example, using the function arrange, and after that, let's create new variable b and write the following code. And after that, if we change element of b, for example, the first element, and after that check the array A, then as you can see, in this case, the variable b is not a copy of a variable a. Both a and b are pointed out to the single data object, the single array, as you can see now. And if you need to create a really copy of array, then you need to use the function copy. Let's try again. The function copy, and after that we again try to change element of b and print both arrays. As you can see, now the variable b is a copy, it is a new array. That's why when we change element of array b, it didn't lead to changing of array a. Dimension of NumPy array is named shape. We can get the shape and change it. Let's consider several examples. Create new array and check the shape. As you can see, the shape shows us the dimension and number of elements. But also we can change shape. For example, let's apply this shape, and now as you can see, we change the dimension of our vector, and we now can consider it as a matrix with 4 rows and 3 columns. And the opposite function is the function flatten. It applies opposite operation, and after applying this function, our matrix is transformed to one row to a vector. And also the useful opportunity of NumPy library is opportunity to point out only parts of shape. Let's consider the next sample. We need to again create array, but also we can use now this array A, and let's change the shape, but using the function reshape, we specify only the first element of desired dimension, desired shape. As you can see, we point out only that we want to create elements with 6 rows, but we didn't specify the number of columns. This value was calculated automatically. Or, for example, we can apply the function reshape with these parameters. In this case, this argument is a number of columns. This argument is a number of rows, and the first argument was calculated automatically, and in this case, the first argument means the number of 2D matrices in our resulting tensor. It's very important to able to assess the required parts of the arrays. Let's consider the several examples. Let's create a new array and after that we can reshape this array. For example, we want to work with matrix 4 by 3 elements, and the first index in these brackets means rows. Let's show the initial matrix first of all, and next 0 element, it's the first row. If we point out the second argument, the second index, then it means that we take the first row and then we take the second element of this row. And the very useful opportunity of NumPy library is opportunity to point out the last element. For example, -1 means that we need to use the last row, but also we can use next previous element and so on. And next important things is working with ranges of elements. For example, we can point out that we want to get rows from second to fourth. In this case, we have only 2 rows. And if we want to use range starting from the start of matrix, then we can point out 0, but also we can just pass this argument, and we can even pass the start and the stop values of our range. In this case, this function gives us all rows. Using this way, we can point out that we want to get all rows and specific column. For example, the second column. And opposite, we can point out a row and then we can specify a range of columns. And so on. The next opportunity is opportunity to point out step. For example, we can specify the start, the stop, and the step. In this case, our processing starts from the second row, then because the step is 2, process will move to the last row, but we point out that we need to stop using this value, and that's why this indexing with ranges returns us only 1 row. But if we pass the start and the stop and using only the value of step 2, then we have 2 rows, the first and the third. And also we can use negative values. For example, we can point out that we want to select the first row, and in this case we will get the first row, and for columns we point out that we need to start from the penultimate element. And the last example is about a negative order of elements. Let's first of all inflate our matrix. As you can see, now we have vector, and let's consider, for example, these parameters of indexing with negative value of the step. As you can see, now the order of elements is negative, and of course we can pass the start and the stop values, arguments, and use only negative value of step. In this case, we just reverse our vector. The next question is indexing with conditions. For example, we can create our sample array again and transform this vector to a matrix. And after that, let's check our matrix. And now we can apply indexing with conditions. For example, we can write condition as argument of indexing into brackets. As you can see, this code selects only elements using this condition. And also we can apply complex condition with operators, with logic rules. And in this case, as you can see, this code selected for us elements using this condition. And also we can create mask, for example, like this, and after that we can use this object for indexing. Sorry, of course, when we create mask, we need to write full condition. Okay, as you can see, these objects allows us to apply it for different arrays or apply it multiple times, and as a result we can save our condition and use it again and again if it is necessary. The next point is the matrix operations. Let's create two array, two vector, and next we can apply different functions for merge these vectors, for concatenate it. The first function is concatenate, and we need to specify concatenated arrays. And as you can see, it just concatenates the first vector with the second vector, or of course you can apply it for matrices. And next function is H, horizontal stack, and also vertical V stack. For example, if we apply horizontal stack for these vectors, then we have the same result as for concatenation. But if we use vertical stack function, then as you can see, the result is a matrix, and each vector now is a row of this matrix. And if we want to apply opposite operation, for example, now C is a matrix, we can split it using the function horizontal split or vertical split. And now we can split this object using the function vertical split or V split, and we need to specify input matrix and number of parts after splitting. For example, in this case, we point out that we want to split this matrix by 2 parts, and it returns these 2 parts. The last question about NumPy arrays is mathematical operations. For example, we can transpose our matrix using this operation, and if you want to apply operations with several matrices, you can use different operations. For example, element-wise addition, or you can apply matrix multiplication element-wise, or you can apply matrix multiplication using this operand. But in this case, we need to transpose the second matrix because it is required by mathematical rules of matrix multiplication. And next example is cross product of vectors. If we have 2 vectors in 3D space, for example, these 2 vectors, then we can use the function cross, and these functions returns us a cross product of vectors. The result is a vector perpendicular to both A and B. And of course, we can apply the simplest operations. For example, we can multiply vector or matrix by constant, or we can easily add constant to each element of vector, and as a result, using NumPy, we can easily realize about all mathematical operators, things that may be need for machine learning applications. For example, we can find maximum, minimum values. Let's consider this example. Create new array, and we can apply the function max. This function returns us maximum element or min function. It is for minimum element. We can calculate sum of all elements or mean, or you can calculate standard deviation, and also we can, for example, get maximum element for each rows or for each column. To do it, we need to point out the argument axis. In this case, we calculate maximum element for each column, and in this case, we have maximum element for each rows, and the additional point is about generation of random arrays. You can use the NumPy submodule random, and it contains a lot of function for create random values, random arrays, matrices with different distribution laws. For example, we can get ranked matrix of random integers, and we can point out the low and high values, range of random values, and shape of output matrix. So we considered basic NumPy functionality for processing data in matrix format, and now we can switch to the example of data preprocessing. We have an Excel file containing data about solar power plant generation and weather conditions. The initial data to work with when solving machine learning problems, as a rule, doesn't allow to immediately apply machine learning methods. The main reasons for this are the follows. Missing values when instead of a number, there is a dash, a question, a space, or another symbol, or maybe just an empty value. Numerical data can be represented in non-numeric format. For example, instead of number 10, the type field indicates 10 kilometers. Also, there are columns with a point as a decimal separator, and there are columns with a comma as the decimal separator. Different column separators, for example, some two different parameters are written in one column and separated by a specific symbol. Date and time are presented as text not a special type of data. Data can contain outliers, wrong values that are recorded in the correct format, but due to a recording error or other reasons, these values were distorted. For example, in a column, hours are recorded in kilowatt, but individual values were accidentally recorded in megawatts. The outlier can distract statistical indicators and can lead to decreasing performance of machine learning methods. It takes too long to manually find and correct such errors. It is easy to miss something. Therefore, it is necessary to be able to automate the data cleaning up. In general, it consists of the following steps: reading the source file, converting columns to the desired formats, detection and removal or correction of gaps, detection and removal or correction of outliers, saving the received file. These steps may be illustrated for the example with the solar power plant dataset. The main Python library for processing the tabular data is pandas for Python. And now we need to create a new Google Colab project and start working with it. To work with table data in Python, the NumPy and pandas library are usually used. They need to be imported. And we need to upload the file with initial dataset in the Google Colab. You can do it manually using this panel of Google Collaboratory and click Upload. After that, we need to select our dataset and wait uploading process. Okay, now we have this file in our environment. And it is possible to read the file and display its beginning as follows. Input df, it is variable for initial data frame, and we apply the function read Excel from pandas library. We need to specify path to our file and the name of it. After that, we can show the head of dataset. It was the first step, reading the source file. Next step is converting columns to the desired formats. It can be seen that some of this work is done automatically. Part of the columns with numerical data is read immediately in the desired numerical format. It is possible to change the read function by specifying options for filling in the gaps. In our case, the dashes and question marks. So we need to modify our function using the argument NA values, and we write that these values we want to consider as gaps. Now, as you can see, these gaps were filling by name. It is the specific value for missing values. And we may check the format of read data using the data types property that is field of our data frame. excuse me, the types. And as you can see now, we have two rightmost columns as of the object data type. That is, they are not perceived as numerical, and the time column too. So this column and these two columns. For processing date and time format, we can use special functions, but let's apply the general approach. Typically, such format errors are corrected by splitting the column into multiple columns and, if necessary, by replacing characters and other modifications. Now, let's create an empty table to enter data with corrections into it. We can name this new data frame as dIfCleared, and first of all, create the empty data frame. And next, what we need to do is to not to miss anything, we will analyze column by column. The data columns does not require mapping, and the times can be split into hours and minutes. And we can just copy the date column and for this column time, we can create temporary data frame, and we can select this column, and then we need to specify that we need to convert the column to string format and then split it by this symbol, and after that we need to convert this part of our data frame, of our data set, as integer numerical value. And we can check this temporary object, but actually we need to add values for our cleared data set. And we create columns hour for record hours, and using the same way we can create a column for minute. And we can check our result after these operations. And next, the columns that require more action. So we can just copy and paste values for these columns. For temperature, lightness, and next day number, and for solar angles and humidity. And of course, actually, we could do the same more easily, but now we analyze column by column not to miss anything. So we apply our preprocessing operations in details with detailed analyze. And let's check. As you can see, the typos. Okay, now we have cleared data set, but it is not the finished stage of our data set, and because also we have two columns, visibility and read speed, and these columns must be processed as follows. Use the column from input, data frame, and then we need to convert to string format. Then we can split and specify splitting symbol and point out that we need to expand values, and also we need to select the first part after splitting, and our next operation is replacing decimal separator. And we need to specify output type of this operation. It is float. And about the same for wind speed. But for wind speed, we want to split using this symbol, or we can use just this part. And in this case, replacing is not necessary, but also, for example, we can use this value, but we will convert it. We will convert kilometers per hour into meters per second by dividing by 3.6. Let's check. Okay. Now we can display the table dimension and analyze the percentage of gaps by columns. For pandas data frame, we can use the same property shape as for NumPy arrays. you can see that now we have 179 rows and 11 columns. And let's print percentage of missing values of gaps. We can use the function isRemove to check is the gap in a row, and then we can sum gaps and divide it by number of rows. And multiply by 100 to show results in percents. Okay, the next step is working with gaps, because several features, several parameters have a significant value of gaps. If there is a lot of data and there are few missing values, then you can simply remove all objects with missing values, remove rows, or remove a feature by which there are many gaps, remove column. But if it isn't, then you need to fill the gaps. There are several approaches. How to choose the most appropriate value to fill each gap. You can use mean, median, or value of the nearest row. Moreover, you can use unsupervised algorithms of machine learning to detect the most similar objects and using their values. But in this example, we can just remove rows with missing values. To do it, we will use the function drop now, and now we create next the second version of our data set and apply function drop NA. After that, we can print a shape of new data frame and also check head of this data frame. No, excuse me, shape. Now you can see that now the count of rows is 116, opposite to the count of rows before removing the gaps. And the fourth step is processing outliers. But first of all, let's check that we remove all gaps. Okay, as you can see, now all values of our dataset contain specific value. There are not missing values, there are not gaps. Okay, the next step is processing outliers. An outlier is an object from a data sample which statistically is very strongly knocked out of it. The problem with outliers is that, on the one hand, outliers can dramatically reduce the quality of training models, since some training algorithms of machine learning are sensitive to outliers. On the other hand, you cannot simply discard outliers because these points may not be erroneous values but relevant examples, the rejection of which will subsequently lead to severe errors at the stage of using the model. Therefore, decision must be made based on an understanding of the nature of outliers. And for visual analysis of outliers, we can use box plot. And Pandas allows us to create simple visualization objects very easily. We need to only call the method of our data frame box plot, and also let's specify fig size, the size of output figure. Okay, it is also possible to build a box plot for temperature only, because as you can see, for this parameter we have a very strange point, and probably it is outlier. To do it, we can use the same code, but we need to specify a parameter column to create box plot. Okay, and now it is obvious that this is an incorrect value, and let's remove the found outlier. And now we can create next version of cleared dataset, and to drop row by condition, we can use the function drop, and we need to read the condition. So we need to point out data frame for applying this condition. Then we need to write condition, and of course we need to specify column and the threshold value, and this part of code index we need to use to drop specific rows. Okay, of course it is not time, it is temperature. Okay, now let's check that we removed this outlier. We can just copy and paste this code. Okay, now you can see that these parameters, this parameter doesn't has outlier, and also we can again create box plot for all parameters. And this point may be an outlier too, but we don't know for sure, so it is better not to delete it. Also, Pandas makes it easy to get data statistics and visualize them. Also, there are more powerful libraries for visualization. For example, we can create histogram of parameters, and we can use the indexing to select several parameters, for example, visibility, next lightness, wind speed, and humidity, and apply the function to hist with fixed size, for example, 6 by 6. Okay, now as you can see, we created histograms for each parameter, and also we can get statistical indicators using the function describe. Now you can see a count of elements for each parameter, mean value, standard deviation, minimum, maximum values, and quartiles. And the last step is writing dataset to an output file. And we can read and write not only Excel file, we can also read or write files with CSV format and other different formats. Now let's save our data frame as Excel file, and we can do it using the following function to Excel. As you can see, there are several options to save data frame. We select to Excel, and we need to write name of output file, for example, solar cleared data. It's all. After that, you need to refresh this panel, and as you can see, now we have this output file, and you can download it and open in your local machine. So we have considered mathematical objects for representing data, a Python library NumPy for working with them with vectors, matrices, tensors, arrays, a data cleaning process, and an example of preprocessing dataset for a solar power plant generation using pandas. As an appendix to the first laboratory session, I propose to consider a number of code samples of using pandas. First of all, we need to import the library. And the first part is about reading input files. As you can see, I added several sample files in CSV and TXT formats. We can use the function read CSV for read file in text format. and we can check a result by opening this file in Google Collaboratory. Let's read next file. Now, as you can see, we have an error. The cause of this error may be a different format of this file, and moreover, if we try to open it using Google Colab, we have error again. So in this case, we can just use the standard function of reading text file without parentheses. We can do it using the next code sample. We just open this file for reading and then read the first line, and after that close our file. As you can see, in this case, each column separate using not a comma or semicolon, but tabular symbol. It means that we need to change our code for reading this file, and we should point out separator. Now, as you can see, we can read this file, but also do you see something strange? Yes, the decimal separator now is comma. Let's now check the data type. Using the property dtypes. As you can see, all types are objects. It means that our reading function cannot understand that these data are numerical data, and we need to fix it. To do it, we can specify decimal separator, and we need to again modify our reading function. We need to use the argument decimal and specify that in this file as decimal separator, comma is used. Okay, and now we have results in numerical format, and we can again check it. Okay, now we can process this data as float type. Next question is column names. Read CSV function has additional parameter named header, and if we use none, then you can see that this row is used as data row, but if we use the default value of header 0, then this row is used as column names, as header. And we can change column names when we read file. Let's consider the next sample. We can use argument names and write column names. For example, these names. And as you can see, now we add our names for each column. And we can do the same for rows. And let's consider the next sample of input file. As you can see, now these values are used as data values. But if we want to point out that these values are row names or indexes, then we can do it using the next code. We need to use the argument index call, and now it means that the first column is not a part of data, but it is a names of rows. And let's consider this code. As you can see, we can get names of columns and moreover, we can change it. For example, using the new names. And now we modified names of each column. And of course, we can also modify names of rows using the property index. For example, let's use new names for each row. Okay, as you can see, now we change row names. And for the next part, we will read file from Google Drive. It is Excel file, and as you can see, I use link to this file for reading it. Also, I use several arguments, header, names, and try to read it. It contains time series of overload of two consumers, reading files from Google Drive, or for example, Dropbox or other cloud platform by the direct link. It is very usable. You don't need to upload files to Colab, but of course, you need to make access to a file for anyone with this link. And if the file contains something secret information, then you should not to do this. In this case, you can use the following code. You can mount your drive, and as you can see, this operation requires process of authorization, and using this link, you can get authorization code. Now, as you can see, my Google Drive folder was added to two files, and I can access. I have access for all files in my Google Drive. For example, I can read file specifying full path to this file, and in this case, I don't need to make access to my file for anyone with the link. because in this case, using the authorization procedure, I can have access for my Google Drive. Okay, but let's return to the consumers. And the next part of this session is about indexing. As for NumPy array, we can get parts of a pandas data frame using the function ilog and rules of indexing and slicing. Let's consider this example. In this case, you can use several arguments: start, stop, step, the first part for rows and the second part for columns. In this case, I use negative step, and as a result, I have a reverse order of rows. And also I specify that I need to use calls from the second, and now I select only two columns without the column with 0 index timestamp. And of course, I can use all columns and point out that I want to select several rows in this range and without step. Or using this function, I can select one element. So this property ilog works as the same way as indexing for NumPy arrays. Also, the property log, it uses names of column and rows. Let's consider an example. And please pay attention to that these values are not positions. These values are row names. For example, if we remove the first row, I create new temporary variable, and I select all rows without the first. Let's check the result. Okay, as you can see, now we removed the first row. Let's compare the results of function of property ilog. Now it means the first row counting from 0. This row. But if we use log and point out the same value as index, then now it means the row with name 1. This row. In addition, we can use column names without properties, using only brackets. For example, now we select only timestamp and logged one. And the last point is about selection using conditions. For example, we can select all rows with value of load 1 more than a threshold. And of course, we can apply complex conditions with logical rules, logical operators. For example, we can add the second part to this condition, and as a result, we have this simple filter, this simple selection. And this gives us a lot of opportunities for processing data frames. For example, splitting data frames, applying a lot of types of calculations, calculate statistic indicators, merge different data frames, and so on. And as the last example, let's consider this code. For example, we want to calculate difference between loads of the first consumer and the second, and we need to add new column, for example, load difference, and we can just write this code as you can see. We can process a data frame as a matrix. That's all. Thank you for your attention.